Good afternoon, sir.
I want to share some research experience which we are doing air pollution, air quality, and also the characteristics of air pollutants and how these air pollutants impact on
Very
animal models. So just we start with ಇದು ಕಾಣಿಸ್ತಾ ಇರ್ತದೆ ಓಕೆ
so you make it a full screen, sir. Full screen, please.
ಇದು ಫುಲ್ ಬರುತ್ತೆ ಸ್ಲೈಡ್ಸ್ ಅಂತ ಈಗ ಓಕೆ
Okay, sir. Continue, sir.
Okay, sir. It's visible.
So today we want to share some experience about air pollution, air quality, emission of this industrial emissions and its impact. Okay. So industrial emissions at present a serious threat to natural ecosystem and human health at a global and regional levels. Subarctic regions previously considered to be one of the largest pristine ecosystem in the world are nowadays subjected to increasing pressure on mining and also smelting activities. In northern regions, the mineral industries contribute significantly to environmental damage and deterioration in the Arctic region. The first Arctic monitoring and assessment program clearly identified the non-ferrous metal smelters as the largest, that is mainly an anthropogenic source of acidifying this air pollution with Arctic regions. The non-ferrous metal smelters are operated by metallurgical company, one of the world's largest producers nickel, palladium, platinum, cobalt, copper, and the largest in non-ferrous metal sectors. So these subarctic and Arctic regions smelters together contributing about 68% of total harmful emissions from non-ferrous metal productions. Okay. The long-term emission or long-term effect on air emissions of industrial components. Largest source of sulfur dioxide and fine particulate matter emissions created vast industrial and technogenic and barrens with the forest ecosystems near the pollution sources. Over the last 20 years, the significant emissions of this air pollutants achieved by the smelting complexes of Ola MMC has resulted impact on vegetation, and however, is continuing the emission contaminants into the atmosphere, secondary air pollution, soil pollution, and accumulated levels of contaminant metals, the surface soils. It's difficult to recover the vegetation near the complexes. So industrial activities are the responsible for pollution on massive scale. So that's why a special laws exist to prevent and control the pollution, particularly air pollution, from factories, power plants, and other large-scale industrial activities. So emissions from different industrial sectors are characterized by wide range of pollutants depending on the industrial sector, type of technology they are used, and the effect to reduce the morbidity and the mortality that can result from exposure to these pollutants, the Ministry of Environmental Protection imposes emission limits upon companies, conduct factory inspections, and more. See, wherever you see the industries, industrial location, so this is a continuous emission of effluent or continuous emission of this air pollutant into the atmosphere. Imagine how this the emissions in the chimney contributing, particularly the air quality, how it is deteriorating the quality of the air which we are taking. So emission from industry, the main industrial sectors responsible for this air pollution are petrochemical industries, chemical industries, mineral industries, that is mining and quarrying, and the metal production and processing, as well as the additional activities. Okay. The main industrial process that emit pollutants are the combustion fuels such as fuel oil, gas oils, etc. And these emissions usually categorized in two ways. That is, there are two types of emissions, industrial emissions. One is a point source emission, and another one is a non-point source emissions. So this point source emission channeled through a pipe such as chimneys, stocks, or any vents. So which you saw that previous slide. Okay. Whereas in non-point source, emission caused by direct contact between volatile substances or particulate matter into the environment. So these emissions may originate from the field sources. So it may be in non-point sources which generating someplace and it is released into the any system that may mix into the environment. It is usually called as a non-point source and point sources. Okay. So emission of this effluent or emission of air pollutants based on the source, it has divided into two types: point sources and non-point source. So we'll see what is the industry and the environment. Okay. So industry is the production of goods or related services within the economy. The major source of revenue of a group of or company is the indicator of its relevant industry. When a large group of multi-sources revenue generation, it is considered to be working in different industries. Okay. But in environment, environment is everything in that around. So it carries living and non-living things. It includes physical, chemical, and other natural forces. The living things live in their environment. They constantly interact with each other, and they change in response in condition in that the environment. So that is, it's nothing but the interrelation or interaction between non-living and living things in a particular habitat or in a particular area or in a particular ecosystem. Okay. The relationship between industry and environment, if you take, the industrial activities contributes a lot of toxic waste to the environment in general. Hence, this presentation is to aware the effect of industrial effluents on the neighboring surroundings to explain eventually how this industrial age on which we build our society, which has affected on the environment. So when we see the industry comprises a lot of numerous organizations in a group building in order to presentation, we have to take on a major three categories of this industrial emissions or industrial pollution are affecting the environment tremendously. These are chemical industry, mining industries, and energy industry. What is chemical industries is the companies that produce industrial chemicals to the modern world economy. It converts raw materials. Nearly about more than 70,000 different types of products we are producing from the different types of chemicals we are producing from chemical industries. So there are many chemical firms on a planet today, and it encouraging to see that at least some of these have made real commitments to lowering their quality of rates and but the company is swearing vaccines, waterways, among many other pollution affect the afferent and the regulators to seem to be prepared to allow that to keep happening. But it is difficult to fight the huge institutions when they have industrial and governmental support. Chemicals is an excellent example of this. The level of activism against them is huge, but nothing seems to be changed. Nevertheless, the environmental groups are continuing to put pressure on these types of companies and with more heads of state stating that important actions are being taken towards preventing climate change. Maybe there will be a change soon. Whereas in mining industry is the extraction of valuable minerals or other geological materials from the earth, usually from the ore body, lodge and the vein, reef or placer deposits. So these deposits form a mineralized package that is of economic interest. That is of economic interest. So mining operations usually create a negative environmental impact both during the mining activities and after the mine is closed. Hence, most of the world's nations has passed regulations to decrease the impact. And work safety has long has been a concern with the aware and modern practical practices have significantly improved safety in mines. Unfortunately, most of the world's highly polluting mines are found in developing and also underdeveloped countries. The environmental regulations often do not exist there. If they do, they can easily be bypassed through corruption. This clearly is a huge problem in the world today. We see the website of Jharkhand government says that the forests in Jharkhand cover about 29% of the state's total geographical area. Okay. Now feeding the minerals to meet the nation's unstable appetite has taken to all on the state rampant mining for decades has turned a large tax of the forest into wastelands. But in the energy industry, so energy industry is the totality of all of the industries involved in the production, sale of energy, including fuel extractions, manufacturing, refining, and distribution. So modern society consumes large amounts of fuel, and energy industry is a crucial part for the manufacture and maintenance of the society in almost all countries. This industry as an amalgamation of all different industries together, which are as follows. So that is petroleum, gas industry, electro power, nuclear, and power energy. Okay, so which contributes a lot of emissions that see this. The percentage, if you take the percentage of contribution of air pollution, say for the index from the industrial sector, it is about 51% air pollutants contributing, and next to that transportation next area. So next the waste generating, what is urban waste we are generating and burning the waste, that is the other one, and others. So that means the air quality deteriorating or air pollution is major contribution from the energy industry, manufacturing and construction industry, and industrial processes. Okay, so energy industry is contributing 31%, manufacturing industry is 13%, and 7%.
ಬಂದ್ರು ಆರ್ಡರ್ ಕಾಪಿ ಹೆಚ್ಚು ರಿಟರ್ನ್ ಕಳಿಸ್ತೀವಿ.
Okay.
ಟ್ರೈನಿಂಗ್
Hello.
ಎಣ್ಣೆ ತಾರೀಕೆ ರಿಲೀವ್ ಆಗಿದೆ.
Yeah, somebody is talking. Okay. Let me see. Is there any pollution started earlier or any history for this? Air pollution. Yes. So air pollution on the earth originated when the man started using firewood for cooking and heating purposes. Hippocrates, 400 BC, a father of medicine, has written 80 medicine reports. Okay, he had written about air pollution prevailing even those ancient times. Yeah, he has identified there is a pollution, air pollution caused by many agents. Okay, and Edward 1200 AD ordered the first anti-pollution law in 1273 to restrict people from using coal for domestic heating. And the year 1300, another law was enacted in London, banning the use of coal and prescribing capital punishment for defense of this law. What is it? So this air pollution is a gaseous and particles in the air that are unhealthy for humans, plants, and animals. Any gaseous or particulate component which brings undesirable change and which brings changes impact on human health, the plant or the animal, they are considered as the air pollution. What is this? Air quality index indicates that whether the pollutant levels in air may cause health concerns. So there is a air quality index given by a pollution control board, state and central pollution control boards, and ISO, and also WHO is measuring using this air quality index. Okay, so indicates whether the pollutant levels in the air may cause health concerns. It has some range from 0 to 500. Okay, so when you see the air quality index 0 is the least concern. There is no point of calling the pollution in that point. So when it reaches 200, 150, more than that is the greatest concern. That shows some quality index. So that is called air quality index to see. So the parameters to certain value 0 to in between 500. Okay, so this is National Ambient Air Quality Standard. See this, for example, a new standard, so Schedule 8 says Rule B 2009, the concentration of ambient air. The standards given by Central Pollution Control Board and also WHO also is following. Okay, so type of pollutant, time, average time to expose, and the area, industrial area, residential area or rural area, and ecologically sensitive area. It has divided like this. Okay, so the concentration standards in the industrial, residential and rural area and ecological sensitive areas. What do you mean by this ecological sensitive areas? Okay, so ecological sensitive area other than this industrial, residential and rural area, mainly on national parks, okay, or the sanctuaries, biodiversity areas, or where this protected animals, the forest areas, it is considered as a sensitive areas notified by central government. Okay, for example, the sulfur dioxide annual exposure, annual average 50 microgram per cubic meter in industrial area, residential and rural, should not exceed 50 microgram per cubic meter in annual average. But in ecological sensitive areas, should not exceed 20 microgram per cubic meter. Okay, so but in sulfur dioxide in 24 hours should not exceed 80 microgram per cubic meter. But in even in ecologically sensitive, not exceed 80 microgram per cubic meter. Okay. So for example, sulfur dioxide. So sulfur dioxide annual average 50 in residential, industrial, rural area. 24, 80 microgram. Okay. So that how it is going to be measured this. So there is a methodology for measuring, that is ultraviolet fluorescent method or improved West improvement method. So that is the instruments they are using to measure this sulfur dioxide in different seasons. Then oxides of nitrogen, NO2. So annual average 40 microgram per cubic meter. 24 is 80 microgram per cubic meter in industrial, residential and rural areas. Should not exceed that. Okay. I'll show you that how much exceeded the next further slides that reported. Okay. So whereas in ecologically sensitive areas, it should not exceed 30 microgram in annual average, not exceed in 80 microgram in annual average. Okay. There is a specific methods to measure this. Chemiluminescence, okay, chemiluminescence method or sodium arsenate method or modified Jacob methods. They're using the instruments and the methodology to measure this oxides of nitrogen or sulfur dioxides. But then particulate matters. Particulate matters, that is in the size less than 10 pm, particulate microgram meters. So that is in 24 hours, it should not exceed 100 microgram per cubic meter. In annual average, should not exceed 60 microgram in industrial, residential or rural areas. Whereas in ecologically sensitive areas, not exceed 60 in annual average, not exceeding 100 in annual average. So this particulate matter analysis method is, they'll use gravimetric method and even Envirotech method. They released a new type of instrument that we are using in the laboratories. So by using that, we are analyzing this particulate matter. We are also collecting this particulate matter in the from Mysore and in and around Mysore and also Bangalore. That we are doing this research we are doing. Even particulate matter 2.5 also. So in annual average 40, 24 hours, that is should not exceed 60 microgram per cubic meter. Okay. So same as the instruments are using the same gravimetric method, and Envirotech released Pollution Control Board has given the permission to use that Envirotech instruments to analyze the particulate matter. Okay. Whereas in lead, so lead is a heavy metal, so that is annual average, it should not exceed 0.5 microgram per cubic meter, but in 24 hours, 1 microgram per cubic meter. Okay, this can be analyzed using this atomic absorption or ED or XRF method or Teflon filter paper method. So they will use the different equivalent filter papers to analyze this lead pollution, lead emissions in the industrial area. Like that, ozone is a ground level ozone, not atmospheric ozone. That is a ground level ozone. It is a pollutant. Okay. So in 8 hours, it should not exceed 100 microgram in residential area, and also in sensitive areas. In 1 hour, 180 microgram per cubic meter. Even in sensitive area also 180 microgram per cubic meter. In 24 hours, it should not exceed 60 microgram per cubic meter. Okay. So this ozone is measured by photometric method, chemiluminescence method, or chemical methods. There are many chemical methods for analyzing this ozone, ground level ozone. It's a pollutant, that secondary air pollutant it is. Okay. Whereas in ammonia, annual average 100, 24 hours average it is 400, and even the sensitive area also, the same indophenol blue method we are doing, and even chemiluminescence also they can do this analyzing this air in the samples. Okay, so benzene annual average 5 microgram, when arsenic 6 microgram, nickel 20 microgram in residential industrial areas, whereas in sensitive areas 1 arsenic in 6, 20 in. So all these three, they'll use HPLC extraction method, they'll use atomic absorption spectroscopy method, and also using equivalent the filter, the EPM 2000 filter papers. So this shows the sensitive areas, how much air pollutant should be, and even the residential areas, how much it's per average, annual average, and 24 hours average. That is given by Central Pollution Control Board prescribed rules and ISO. Even WHO also mentioning this, the air quality index. It should be this, it should not exceed this residential and also in the sensitive areas, that is air quality index. So this is the formula they will use to calculate the air quality index. I is equal to IH and high H minus high low divided by C high and what is this? High means the air quality index, C the pollutant concentration, C low the concentration break point, and this is the formula they will use according to the EPA pollutant break point. Okay, we will use this formula to calculate this air quality index. Okay, so this is the formula we are reading. Yeah, this is the air quality index. See, it clearly says, I told you the value 0 to 50. The air quality index value 0 to 50, it is good. The health levels of a health concern is good. And health effects is little or no risk. If the air quality index in any area, you want to see, so that is 0.50 good and little or no risk. 50 to 100, it is moderate. Acceptable quality. The air quality index, if 50 to 100 where you observe, so that may be the moderate, you can acceptable, the quality, air quality is acceptable. But it is in 100 to 150 air quality index, the value, unhealthy for sensitive groups. Sensitive groups means children or the people who are more susceptible towards disease or the people who are suffering any respiratory risk. So they are sensitive, so that should not, that is unhealthy for health concerns. Unhealthy for sensitive groups and general public not likely. Okay. If the air quality index value 151 to 200, it says unhealthy in human health concerns and all may experience some risk. Okay. And if the air quality index is 201 to 300, very unhealthy. So all may experience more impact, effects. If 301 to 500, it is hazardous, emergency conditions. Okay, let me see what are the places they have identified unhealthy or healthy or moderate and good. Okay, so this is the air quality index. The color indicates and also the value which indicates to see the quality. It tells you the quality of our air in and around. Okay. Yeah, see this. So this diagram shows the color, the extreme. See, for example, India extreme, Bangladesh extreme, Thailand extreme, Hong Kong extreme. Okay, Myanmar, Nepal, South Korea. So that here the color indicates shows extreme risk, high risk, and medium risk, and low risk. See the color that is China and also our country, India, and other parts is indicating the light pink color. That shows the intensity of the air pollutants in that area. Okay. So in the worldwide, you can see this air quality index by this color depicting the colors. Okay. So then WHO releases new global air pollution data in 2018 it is. Okay. See now India is 130, 140, that is the most polluted point. See that in other countries that is in fine particulate matter 2.5 based on average of 10 most polluted cities in each country. Based on average of 10 most polluted cities in each country. Okay, so that is, it shows the value of this. What is the 10, 20, 30, 40? It is in the value of 2.5. Okay, air quality index, the value of 2.5. So which was the highest, India, followed by China, Pakistan, Egypt, and also Nepal. So the permissible limits of this 2.5 is 40 to 60. Okay, so where this 40 to 60 it exhibits, so that may be the WHO is acceptable, and even the air quality index is acceptable. So more than that, that is moderate or highly risk and also not healthy, the quality of air. Okay, see this 20 worst cities worldwide for air pollution. Okay, so annual mean microgram per cubic meter of PM in cities worldwide. So this is the values, the air quality index value 594, 540, 527, 448, 423, 371. Not all the cities, that is some cities identified here. Okay, so that for example, Gwalior in India 329, some city, that city area, average. That is the mean microgram per cubic meter they have taken. Okay, so that is in Karachi 290, whereas in Raipur 268. That is the value of air quality index. So which shows the quality of that environment, the quality of the air in that city. Okay. So this is one critical issue in Afghanistan, the pollution in Afghanistan, air pollution state. So air pollution, see the severe, high, moderate, low, very low. So that shows the one example, right? See, this is our Indian air quality in India. So that is air quality in India, major cities is fast deteriorating. For example, I showed this air quality index. Okay, so last year, that is 2019. Okay, 18-19 survey report it is. So that means, so Delhi is showing 182, Lucknow 163, whereas in Chennai 179, Pune 1210, Bangalore see highest, Bangalore 310. Okay, so this report is last year, that is 2018-19 report given by World Health Organization, WHO. Okay, WHO survey last year found that 13 of the most polluted 20 cities in the worldwide in India. Okay, then the last year environmental prevention, India ranked about India, it is 174 out of 178 countries. Okay, air quality index that we are showing. Okay, so this shows some report and also the relation between industrial emission and the environment, and how this air quality index tells you the quality of air, and how it is good, moderate. If the air quality index is low, it is good for good in that environment, or in air quality index is high, the surrounding air quality is bad. That tells you based on the value and the calculation of that air in that particular area. Okay, so this is a little bit the methodology which we are, our research point I'm telling you now. So research point, how we are going to collect the samples and do this in a laboratory condition to say the characteristics of that air pollutant and to see the impact of that extracted air pollutants into the animal model. Okay, just a methodology what we are followed. So this is the RSPM, TSPM and PM10. Because this is the instrument we have now in our laboratory. We got the DST project. Okay, last year we purchased this instruments from Envirotech department. So the permission, the Pollution Control Board given the authority and also the license to buy the instruments from Envirotech. Okay, so Delhi, that laboratory. So we brought this instrument to collect this TSPM, total suspended particulate matter, or PM10. This is meant for only PM10 and total suspended particulate matter, which we are collecting, particularly in Mysore. We are divided three regions. We divided the area into three regions. So one is the highly polluted area. Another one is moderately polluted areas, and another zone less polluted zone. So in three zones, in the radius of 6 kilometers, we have taken the radius of 6 kilometers in the major center of the city. That is called polluted area. Moderately polluted area after 6 kilometers or in and around the periphery of the ring road, below the ring road, that is called a moderate polluted area. And outer ring road area, that we consider as the non-polluted or less polluted zone. Okay. So this instrument, we have these three instruments, this only PM10 and also TSPM. So we are placing this in three places. By running this instrument, there is a automatic system is there and also the manual mode is there. So for that we are running this instrument by collecting the PM10 in moderate and also highly polluted and less polluted zones for 24 hours. We will continuously run this instrument for 10 days. Okay. So the flow rate is 0.19 to 1.4 cubic meter per minute flow rate. It is, we will set, and particulates is 10 micron collection. So we'll use the filter papers supplied by Envirotech. Okay. So SPM larger than PM10, that is collected total SPM here, and PM10 there is a filter paper where we will keep this, and sampling time is 24 hours maximum per day, and sampling time recorded automatically, and also the manually we can set up, and we'll run this program. So thus, so the PM10 is going to collect this point, and total suspended particulate matter is to collect this lower region. Okay. So this is the instrument we are using for collection of particulate matter PM10 to a total suspended particulate matter and PM10 by using this Envirotech supplied instrument, by using the filter, and down there is a collection of TSPM. Okay. So PM10 and TSPM. Okay. So this is a working model, how this air suction inlet and followed by the filter 1 and the total collection TSPM, and above that the 10 PM is flows above the surface, and also it settles on the filter paper. Okay. So this way we are using. So this is the sample we are collected. Okay. So how does it looks, the TSPM after the collection of this instrument, that is in microscopic view. So this like this you see like black carbon. So this is a particulate matter. Particulate matter, total suspended particulate matter PM10 and TSPM. Okay. See this like this it is. So if you use before collection, the paper, white paper, the filter paper looks like this, white, colorless. Okay. So partially one day if you run this instrument, you will get like this partially, and completely filled particulate matter in that instrument. You are going to observe like this black, the white colorless paper, white paper converts into this. It's the standard filter paper and the coated filter paper, and also the code. They'll give the code of that, and they supplied by Envirotech company, which we purchased, and also we are doing this. Okay. So this is the 2.5 dust samplers. The particulate matter 2.5. This instrument we are using. The same way that is in the three instruments we have this. So we have divided three regions in Mysore. We are collecting this by using this automatic sampling and also manual sampling. So that we will run. So this is only meant for 2.5 PM particulate matter collection. Okay. So that this is a filter. It's a small size, and also the Teflon filters we will use, and this is supplied by Envirotech only. So from this we are using to collect 2.5 samples. So 2.5 particulate matter. Okay. And this instrument is used for gaseous samples. Sulfur dioxide will collect, nitrogen dioxide we can collect, and ozone, ground level ozone we can collect, and also ammonia we can do. But each sample, gaseous sample, the chemicals and the medium is totally different. Okay, sulfur dioxide and nitrogen dioxide and also ozone, these are the impingers. So each one has a liquid medium, so that if you run that instrument for 24 hours, so that it absorbs this only the that gaseous pollutants, and that medium will absorb it, and that what the medium we are using in this impingers, so that we are going to analyze by using analytical methods. Okay, to see the concentration of the nitrogen dioxide and sulfur dioxide and oxygen, so that we are using this Envirotech instrument, the gaseous samplers. Okay, so that is the methodology what we are using in the laboratory, that work I found. So then major the industrial pollutants or emissions mainly on these 6 groups. One is 6 common pollutants. One is ground level ozone, lead, sulfur dioxide, particulate matter, nitrogen dioxide, and carbon monoxide. So any air samples if you collect, so mainly they are going to see or observe these 6 common pollutants. That is why 6 common air pollutants contains. Okay, so this is sulfur dioxide. You know, sulfur dioxide is a colorless gas with an pungent odor. It is produced from the combustion of sulfur bearing materials. You know, see, sulfur and oxygen, sulfur dioxide and sulfur trioxide and water molecule, you will get secondary air pollutant, H2SO4. So natural process, also there is a lot of emission of sulfur dioxide, that is carbon volcanoes provide 67%. 67% oxides of sulfur pollution distributes over the globe. So on that, the man source is 33%, fuel combustion, transportation, coal-fired power stations. So this sulfur dioxide combines with oxygen to form a sulfur trioxide, and it binds with water molecule, humidity, so that you get the H2SO4, that is called, this gives rise to the phenomenon of acid rain, which are aerosols. Okay, oxides of nitrogen represents the composite atmosphere gases, nitric oxides and nitrogen dioxides, primarily involved in air pollution. So it's also a colorless gas and odorless gas, but NO2 has the brown color and pungent suffocating odor. So nitrogen binds with oxygen to form a NO2 oxides of nitrogen in different forms. It is in the presence of sunlight. Okay, in the presence of oxygen. So the distribution of oxides of nitrogen from natural sources is more or less uniform in the global. The man-made sources varies depending on the urban and rural areas. Okay. In urban atmosphere, oxides of nitrogen tend to 100 times greater than in rural areas. How this carbon, this incomplete combustion process, this carbon monoxide formed, and carbon monoxide is also a formed pollutant when hydrocarbon fuels or natural gases are burned, incomplete burning. So the oxidation of carbon monoxide, there is a reaction how this oxidation takes place, and also this carbon monoxide to carbon dioxide. Then the ozone is an unstable gas with a characteristic of fresh pungent odor. The smell is noticeable after thunderstorms, where this form the flashes of lightning. And while the naturally occurring ozone is upper atmosphere over the layer, it protects them. Okay, so ozone is not emitted directly from any man-made sources in significant quantities, but it is formed in a complex. So ozone precursor emissions, that is a man-made sources, oxides of nitrogen, volatile organic compounds combustion. Okay. And natural process, natural sources, volatile organic compounds, the oxides of nitrogen and concentration depends. Okay. The source location, density and strength and meteorology. There is the factors, temperature, humidity. So based on this, the concentration depends on meteorology. The concentration depends on source location, density, strength. Okay. So natural source and also man-made source and depends on this. You know, ozone chemistry, I think it's a detailed information about you, summary of ozone chemistry that I think this detail. The production, that is the RO2, that is a reactive organic compounds such as volatile organic compounds, binds with ozone to form a ground level ozones. Okay. So once formed, this ozone can remain in the atmosphere for many days, and it is often transported over long distances. It is for this reason that a real reduction in ozone levels only achieved through global action by everyone. Yeah, lead is the main source. Lead is in the atmosphere historically been formed in the combustion of the vehicles, and since the phasing out of lead petrol airborne and lead levels have fallen dramatically, lead no longer the major. Whereas in particulate matter, PM is a complex mixture of airborne particles that is different in size, origin, and also chemical. So that is PM, SPM, RSPM, respirable suspended particles, fine particles, and shoot. It has 5 categories in this. Okay. So the facts about PM pollution. PM is one of the 6 EPA criteria pollutant. Okay. So PM has no fixed composition. The particulate matter consists of either only one chemical or many chemicals, a number of pollutants, okay, organic or metals or any other compounds. So it's a combination of many. Okay. So EPA described PM pollutant as a mixture of mixtures. Hence, the mixture of mixtures, particulate matter is a mixture of mixtures. Pollution has mixture of mixtures. So PM is among the most harmful of all air pollutants. Okay. So primary, directly emitted from source. Secondary, form as a result of the interaction of chemicals such as sulfur dioxide, oxides of nitrogen, and volatile organic compound and other compounds. So this PM will react with all 5 air pollutants. All 5 air pollutants, and also it binds with secondary air pollutants also. So that is why Environmental Protection Agency, even pollution control boards categorize the particulate matter is a pollutant mixture of mixtures. Okay, there is no definite composition in this. Okay, that's why it's called a mixture of mixture. Okay, PM10 is a coarse particle, fine particle PM2.5, you can call it as ultra fine, it is a less than 0.2. The size comparison, okay, PM2.5 is a soot particle, PM10 is a dust particle. See, the size of the human hair, 50 to 70 micron meter. Okay, well, see the PM10, where is half of that 10 times smaller in that. Okay, so PM9, the fine beach sand is PM90. Okay, so human hair is 50 to 70 micron. Okay, PM10 is 10 microns, 2.5 below that. That means smaller than 10 times smaller than the air. That is PM10, respirable. Okay, see these characteristics of this PM10. Inhale coarse particles, diameter range 10 to 2.5 microns, undergo rapid sedimentation, which occur roadway and also dust industries, and bypass by bodies, natural defenses, and nose and throat it enters, and also it enters into the lung. And PM2.5 particles particle diameter 2.5, so remains suspended in the air and can travel extremely long distance, emitted from power plant and industries and automobiles, and penetrate, 2.5 pm penetrate deeper into the lungs and damage lung tissues. So then PM1, it is ultrafine particles, nanoparticles, smaller than 0.1 micron diameter, consists primarily inorganic ions, hydrocarbons, and metals. Okay, so pass from lung tissues into bloodstream. Nano PM1, PM0.1 circulates like oxygen molecules into the circulatory system. Okay, so particulate matter is a complex mixture of solid and liquid particles. It's a composed of many different compounds, both primary and secondary pollutant, as I said earlier, and size varies tremendously. Okay, forms in many ways. PM is clean air levels, and background concentration can be higher due to the dust and also smoke, and concentration range from 0 to 5 microgram per cubic meter, and health concerns can aggravate heart diseases associated with cardiac rhythms, and can aggravate lung diseases, asthma and bronchitis, can increase susceptibility in the infection. Okay, this side. Okay, see the pollution air. What are the industries categorized? Based on convenient, it has been divided into 3 categories. And what is the status of air quality index in India and also other parts? Some examples, and how this air pollutants collection, and what are the instruments they'll use for the collection of this air pollutants, gaseous and also the particulate matter. Okay, the characteristics of these air pollutants, 5 air pollutants in brief, not in detail. See, if you take oxides of nitrogen in the health impacts, you will get a lot of information. Or if you take oxides of sulfur dioxide, there is a mechanism, there is a separate mechanism how it triggers, that is the molecular level research that we are not just in a brief. Okay, so then how these industrial emissions effect on environment and effect on animal and effect on the plant. In brief, on small information, not in detail, just small information about this industrial emissions effect. Okay, so the increase in the concentration of carbon dioxide and other greenhouse gases like oxides of nitrogen, sulfur dioxide, or chlorine. Okay, water vapor are responsible for increasing temperature. That greenhouse gases and other the gases trap the Earth's heat and cause global warming, so which will have the following effects on environment mainly. Okay, so due to global warming is one, that is the contribution of this greenhouse gases, warming of the Earth's atmosphere. So then you will get this global warming. That's global warming. The regions of the northern hemisphere heat up more than other areas of the planet. In the temperature maintain the snow lines and will melt earlier. Okay, so winter and night time temperature will tend to rise more than the summer and daytime. So rising the warmth will lead an increase in the level of evaporation on surface water, and air will also expand, and this will increase its capacity to hold moisture. So this in turn will affect the water resources and forests and other natural ecological systems, agriculture and power generation. Okay. So due to excess heat, water will evaporate quickly. Okay. So the soil affected with erosion and devoid of vegetative cover will not retain moisture long time. Hence, there would be, it leads to the drought conditions. Okay, the rise in temperature would lead to the melting of glaciers, which will form a natural lake between the mounds of debris and rocks that left behind by the sliding glaciers. So this will result in imbalance in the outflow of water. This means that the glacial lakes will be fed with form of melting of ice faster than the rate at which they can drain, making glacier lakes and flood more frequently. So deltas will be threatened by flooding, erosion, and also salt intrusions of coastal mangroves. So will have an impact on fisheries. For example, major delta areas of Ganga, Brahmaputra, and Indus River, which have large population, will affected by floods, salt water intrusions, and land loss. Okay. Uh, then on effect on human health, so to the extent to which human beings are affected by air pollution depends on the duration of exposure and the concerns of the pollutants. Based on the criteria, the air pollutants have both short and long-term effect on human health. Okay, so the short-term effect, if expose a less duration, short-term effects of air pollutants are irritation in eyes, nose, and the throat, and respiratory infections such as bronchitis and pneumonia, and headache, nausea, vomiting, dizziness, convulsions, and also allergic reactions, and slurring of speech. Okay, maybe slurring of speech. Short term. Okay. So this table shows the specific pollutant and the specific effect on human health. Sulfur dioxide obstructing breathing causes irritation of eyes. Suspended particulate may cause asthma, throat infections. Oxides of nitrogen cause acute respiratory infection, bronchitis, lower resistance of influenza. Hydrocarbons mainly on respiratory system. Ozone causes irritation of eyes and aggravates asthma. Arsenic damages the teeth, causes damage to lung and skin cancers. Okay. In long-term effects, if it continues, suppose the persons who are working in the industries, okay, or the person continuously exposing in traffic areas, or the person continuously working in industries in a long time, okay, so that it may leads the chronic respiratory disease and lung cancer and cardiovascular disease, coma, and damages to the nerve or brain and liver and also the kidney. And this already shown this. Okay. So on plants, see, air pollutants affect on growth of plant and also the metabolism by destroying chlorophyll and disrupting the photosynthesis. See, the mechanism is different. Just I am telling the main important point, the chlorophyll and disrupting the photosynthesis. So the effect of air pollutants on plants are the sulfur dioxide bleaches the surface of the leaves, which causes loss of chlorophyll and result in yellowing of the leaves, especially in green leaf vegetables. Okay, and nitrogen oxide results in the premature falling of leaves, suspended and suppresses the growth of plants. This leads to reduce the yield of crops. Okay, so ozone damages the leaves of the plant, and PIN, it damages the leaf vegetables, cause premature fall and discoloration and curling of the sepals. Okay, so this okay. See what to do is join the revolution and stop the pollution. Okay, so this that the steps taken to control air pollution. See, the Modi government has finalized 837 crores National Clean Air Program to improve the air quality in India particularly. Okay. Setting up of monitoring networks for assessment of ambient air quality, introduction of cleaner and alternate fuels like gaseous fuels, CNG, LPG, ethanol blend, and implementation of stage 5, 63 selected cities and universalization to all, and taxing polluting vehicles and incentivizing hybrid and electric vehicles, ban on burning of leaves and biomass, municipal solid waste. So this is nowadays the biomass burning, municipal solid waste contributing a lot for the air particulate matter and air pollutants. Okay. So promotion of public transport, network of metro, buses and e-rickshaws, and the promotion of carpooling and pollution and control and lane disciplines and vehicle maintenance. So these initiatives taken in all the states, and revision of existing environmental standards for formulation of new standards for prevention and control of air pollution from industries. Okay, revision of emission standards, including the thermal power plants, cement plants, and other industries. Okay, the installation of online continuous monitoring devices by major cities. Okay, now you can observe there are many monitoring stations. So earlier in Mysore, only 2 monitoring stations. Pollution Control Board has fixed only 2 monitoring stations. One is in KSRTC bus stand and another one is the JK Tires nearby. So now there are 7 monitoring stations. Okay, there are 7 monitoring stations in different locations to monitor the 24 hours to get the online information. What is the level of particulate matter, SPM, RSPM, or TSPM in particular area, and what is the level of what is the level of this oxides of nitrogen, level of sulfur dioxide. I think you may observe this in all metro cities, railway stations, and also KSRTC bus stands. How every minute and every hour you will get the report. What is the quality of air? Our air. What is the quality of our air? Okay. So collection of environmental protection charge more than 200 cc diesel vehicles, and ban the import of firecrackers and phasing out of 15 years old diesel vehicles in Delhi. Okay. So these are the steps taken to prevent or to minimize the emissions from industry and also automobiles and also these vehicle sources. Okay. So what we can do? Okay, you observe these 3 websites: EPA, Environmental Protection Agency website. You can see air quality, real-time air quality. You will get in all the. See, if you go to the Karnataka State Pollution Control Board or CPCB, Central Pollution Control Board .nic.in. So you will get air quality in India website, Airveda information, and also air quality real-time information. Okay. So the source the data from air quality stations installed across the country to help to track outdoor air quality university. Okay, that is Airveda. And Air Quality India, an application provides a real-time air quality data from across the India. The data has been measured as per the standard norms given by Central Pollution Control Board in India. Okay, so there you will get it. Okay, so the air quality, that is in real-time air quality, the application shows the real-time air quality index. So more than 60 countries in the world, including China and also Hong Kong, all the places, you will get the quality of air. Every hour you will get the information from these websites. Okay. Okay, see, you can join these groups. Join the group of to stop pollution. These websites you can see. You will get a lot of information. You can search it. You can update the information what is going on, particularly with respect to the air pollution. Okay, so air pollution is an incurable disease. It can only be prevented. You cannot stop it. Total 100%. It can be prevented. Okay. Okay. Thank you. Thank you for patient hearing. Okay.
बाजी उन लोग नाइट के
Thank you, sir. Thank you very much.
उधर जा रहे थे नाइट के टाइम पे हाँ तो भी जाएगी तो इधर बीच में इस साइड तो खबर सारे खाना भेजे थे तो उन्होंने तो ठीक कर
Now, I would like to express vote of thanks, sir, on behalf of my co-participants and on behalf of UGC-HRDC University of Mysore. I express gratitude of thanks from the depth of my heart. Thank you, sir.